Okay, so in this video I'm going to have a look at sketching polynomials. I'm going to do 3 examples. This is the first example here of a polynomial. It has 1, 2, 3, 4, 5 factors. So because we have the factors, we immediately have the roots, so we can have a look at that in a few minutes. But first of all, I just want to have a look at the degree of this polynomial. It has, if you multiply x by x by x by x by x, you'll end up with x to the power of 5. So that means this has a degree of 5, which is an odd degree. Because it has odd degree, that means that one of the arms of this graph will point up and one will point down. Okay, so let's look at our leading coefficient. We can see there's a 1 in front of this x, a 1 in front of this x. There's a 1 in front of each of these x's. So our leading coefficient is going to be positive. It's a plus 1, plus 1, plus 1, plus 1, plus 1. So our leading coefficient, the number in front of our x to the power of 5, is going to be positive. So our leading coefficient is positive. And finally, I'm just going to write down the roots. The roots of this particular function here are going to be x is equal to minus 3, minus 1, 2, 5, and 6. So x is equal to 3, x plus 3 is equal to 0 means x is equal to minus 3, x plus 1 is equal to 0 means x is equal to minus 1, and so on. So these are our roots. So we have an odd degree, leading coefficient positive, and we have our 1, 2, 3, 4, 5 roots. So let's have a look at sketching that graph. Now, I'm going to do this fairly roughly. Obviously, you would use a ruler and do the scales properly. I'm just doing this freehand, so it's going to be a little bit inaccurate, but let's have a look anyway. So we're going to do our y-axis, which will look something like that, and our x-axis, which will look like this. Now we are going from our x's need to go from minus 3 up to 6. So let's say 1, 2, 3. I'll go to 4 here. So minus 1, minus 2, minus 3, minus 4. On this side we got 1, 2, 3, 4, 5, and 6. Now, I know from doing this that I'm going to be talking about a y scale going up as far as 224, and down here it's going to be somewhere around minus 180. Now I did that on my calculator, so if you know how to put functions into your calculator, you should be able to do that fairly easily. Now, we know that we've got an odd degree, which means one arm is going to point up, one arm is going to point down. So because our leading coefficient is positive, the right arm is going to point up. So it's going to start up here and end up down here. So I'll start down here somewhere and we'll work our way up to here. So what we've got to do is we're going to start down here somewhere. It's going to go through minus 3 and then back down through minus 1. So it's going to go something like this, and it's going to go up as far as 224. So we're going to go up as far as somewhere around here. So we're going to go up this way, it's going to turn around, and it's going to come back down through minus 1. Now it has to then go up through 2, 5, and 6. So we've got to go back up through 2, down through 5, and back up through 6. So I'm going to go down. Let's see, it's going to go down something like this, back up through 2, back up again, down through 5, and back up through 6. Okay, a little bit shaky there, but you get the idea. That's what our graph will look like. It's an odd degree, so one arm up, one arm down. Because the leading coefficient is positive, the right arm is up, the left arm is down. and we have our 5 roots as well, -3, -1, 2, 5 and 6. So that's my first example. Let's have a look at second example. Okay, so second example, and that's going to be, let's say, x -2, and we'll have 3 of those, and we've got x +3 here. We'll call this one g of x. So g of x is x minus 2 to the power of 3 times x plus 3. So we have a root here of x is equal to 2, and that has a multiplicity of 3. So we've also got a factor here of x plus 3, which means a root of x is equal to -3. That has multiplicity of 1 if you like. It only appears once. So let's have a look at what, we'll just summarize what we've got here. So in this case we've got a degree of x to the power of 3 here times x, so that's going to be x to the power of 4. So here we've got an even degree of 4. Our leading coefficient, our x to the power of 4, there's a 1 in front here, 1 in front here. So our leading coefficient is positive, and our roots are going to be x is equal to 2, 2, 2 if you like, and -3. So our x is equal to 2 here as a multiplicity of 3, and then we have a -3 here. If x plus 3 is equal to 0, then x equal to -3, and so on and so on. Okay, so this is all the information we need really to sketch our graph. Remember, we're not drawing these graphs. We're not drawing them accurately, we're just sketching them. So let's have a look at this one. So again, we'll do our y-axis, and we'll do an x-axis. Now we're going from 2 to -3, so let's have a look at that. We'll just put in, let's say, -1, -2, -3, -4. Then on this side we've got 1 and 2. We'll put in a 3 as well. I think here we're going to go down roughly as far as -54. Again, I've done this on my calculator, so I know roughly where we're going to go on the y-axis. Now let's draw this, or sketch this rather. So we have an even degree here. Okay, so an even degree means that the arms of the graph are going to point upwards or downwards. Now, because our leading coefficient is positive, both arms are going to point upwards. So it's going to start here and we're going to finish up here somewhere. Both arms are going to point upwards. If the leading coefficient was negative, we would start down here and we would end up down here. Both arms would point downwards. Okay, so now I know roughly what way my graph is going to go. I've got my roots here, which is they're at 2 and -3. So I'm going to start up here. I'm going to go through -3, and then I'm going to go through 2 and back up here. Now, because x is equal to 2 has a multiplicity of 3, what actually happens when we come back up here is that the graph flattens out across the 2 and then goes off in this direction up here. So we're going to start up here. We're going to go down. We're going to come down this way here through -3. Whoops. Let me just adjust that again. I just need to rub that bit out. Okay, let me just... We're going down through -3. We're going to come up along here like this, and we're going to start flattening out here across the 2. So we're going to kind of flatten out across here, and then we're going to go up along here like this. We could even flatten that out a bit more actually across the 2. Okay, just draw one line here. I've kind of flattened it out a bit there. Okay, so it'll look something like this. Okay, So both arms are pointing upwards. One of our roots is at -3, so it goes straight through -3. We have x is equal to 2 has a multiplicity of 3, which is an odd multiplicity, so it's going to flatten out across the 2 here. Okay, and it goes through, because there are 3 2's here, an odd number of 2's, it will go through the x-axis, straight through. If we only had 2 2's here, what would happen is the graph would come up, hit 2, and go back down this way again. It wouldn't actually cross the x-axis, but because we have an odd number of 2's, it'll flatten out across the 2 and then come up along here like this. Okay, so that's our second example. Let's have a look at another one. So our third example here is this one here. So we're going to do x times x plus 7 to the power of 2, x plus 4, and x minus 2 to the power of 2. We'll call this, we'll call it m of x. Okay, so let's have a look at what we've got here. We just summarize what we've got. We've got x times x times x, because there's an x squared here. So x times x times x times x times x times x. So we've got 2, 3, 4, 5, 6. We've got x to the power of 6 here. So that's even degree. So we've got an even degree of 6. We have a coefficient of x here is 1, 1, 1, 1. So we're going to have the leading coefficient. The leading coefficient here is positive. And our roots then, okay, so our roots are going to be, I'm going to start, let's say we start here. No, we'll start here with this x here. This x here is going to be equal to 0. So we've got 0. We've got a -7. We've got another -7 because it's squared here. We've got a -4. We've got a 2. And we've got a 2 because this bracket here is squared. So we've got 2 of those. So we've got 1, 2, 3, 4, 5, 6 roots as we would expect here. Maximum 6 roots because we've got a degree of 6. Okay, so this is all our information that we need to draw the graph. So let's have a look at what way we can draw this. Now, again, we just need to draw the x and y axis. So let's do that. Draw the y-axis down along here, and then we'll draw an x-axis. Again, my drawing skills are not great here, so you're going to have to use a ruler and do it a little bit more accurately than I do, but you get the general idea anyway. So we're going to go down as far as -7, and we're going to go up as far as +2. So I got to go 1, 2, 3, 4, 5, 6, 7. I'll go as far as 8. So we got -1, -2, -3, -4, -5, -6, -7, -8. Now you use a ruler to measure these accurately. I'm just doing it by eye here. So let's see, we got a 1 and we got a 2 here. I'll go out as far as 3. On the y-axis, again using my calculator, I know I'm going to be looking at figures like that's going to be 3,200 up there. I think I need around a 320 here, and a minus 1,200. Okay, so let's look at sketching this and see what we've got. Now, we have even degree, so once it's even degree, we know that the arms are going to point upwards or downwards. Now, because the leading coefficient is positive, I know I'm going to start up here and I'm going to end up here somewhere. So both arms are going to point upwards. If it was, if the leading coefficient was negative, I'd start down here and end up down here. Okay, so now my roots start at -7, -7, -4, 0, 2, and 2. So now I've got a -7. I've got a -7 is a root of multiplicity 2. So because it's an even multiplicity. I'm going to come down here, I'm going to hit 7 because it's an even number of roots of minus 7. I'm not going to cross the x-axis, I'm going to go back up again. Then I'm going to come down here, I'm going to pass through minus 4. Then I'm going to go up here to 0, I'm going to go through 0. 0 is a root. Then I'm going to come down here and I'm going to hit 2. I've got two of these 2's. 2's plus 2 has a multiplicity of 2, so which is even. So I'm going to hit 2 and I'm going to go back up again. So I should end up here somewhere. Now let's start that. So we're going to go down here and we're going to hit the minus 7. So we're going to go down here, hit the minus 7 and go back up again. I'm going to go up and back down through minus 4. So I'm going to go up, back down through minus 4, straight through minus 4, and then going to go down through minus 4, keep going down, and then going to go up through 0. So it's going to go up here through 0. Then I'm going to go down, I'm going to hit 2, and I'm going to go back up again. I'm going to go up here as far as 320, I'm going to go back down, I'm going to hit 2 and back up again here. Okay, if you could try and make this curve a little bit smoother, I'm a little bit shaky here, so the smoother the better. So this is what our graph is going to look like. Now remember, this is a sketch, it's not absolutely accurate. So we started with 2 arms. We know the 2 arms are pointing upwards because it's even degree and the leading coefficient is positive. We have all our roots, so our graph will hit each of these roots. It'll either go through the roots, through the x-axis. It goes through the x-axis at 0 because there's only 1, and minus 4 because there's only 1 of minus 4. It will hit minus 7 but not go through the x-axis because there are 2 minus 7's. It will hit 2 plus 2 but not go through the x-axis because there are 2 2's, an even number of 2's. So that's it really. That's 3 examples of sketching polynomials.